What we were talking about yesterday, we were trying to solve for x. And really, when you're solving for any variable, you got to get rid of everything. You're trying to isolate it, basically. So one of the things we need to get rid of is that square term. So this guy right here. And the way we get rid of a square term is with our root. And since that's a squared term, the way we would get rid of that is with a square root. So we would do that to both sides. You're going to take the square root on the left-hand side. The square root and the square basically cancel each other out. And all you're left with is the x plus a 5. All right. So that's pretty standard. Every problem we've done, we've had to do that. And then what we talked about, with it being an equation, whatever I do to one side, I've got to do to the other. So we're also going to take the square root of the 8. But what we talked about, so quick little reminder so we understand why we were doing this. Yesterday when I gave you 2 or 3 of these in a row. If I gave you that question there, x squared equals a 36, initially everybody gave me the positive answer here. And we thought that was our answer. And then when I told you there was another answer, then we kind of thought a little bit through it. Some of you came up with the idea that a negative 6 squared would also give you that 36. So when we take our square root, understanding that there's both a positive and a negative solution to that is important. So that is why I told you to then, when you take your square root, always put that little plus minus sign in front of it, because that's going to give you both of them. So when we do that with this 8, it's the same thing. When I take that square root, there would be a positive and a negative solution to this. So in that next step, we would write this as a positive and a negative root 8. Okay. Some of these were perfect squares. The root 8 is not a perfect square. So what that then required us to do is to do what we did on our quiz and what you just turned in if you did those corrections. We need to simplify this. Root 8 can be broken down. We never want to leave a perfect square underneath that square root. So 8, one of the easier ones, we know this has to be a 4 and a 2. 4 is going to be that perfect square. And then we know that the square root of 4 is 2. So we're going to write this as plus or minus a 2 root 2. And then at this point, now we finish our solving of this. This is really 2 different equations. So what I've been doing, and I would still kind of recommend this right now, is we've been writing 2 different equations from this step. One of them is x plus 5 equals the positive 2 root 2. So that's the positive one. And then we set up another equation where we take this x plus 5 and we set it equal to the negative 2 root 2. All right? And then we now solve that for x. And it's the normal solving of an equation. If I'm solving this for x, you would subtract 5 from both sides. So we subtract 5, subtract 5. This is going to be gone. The x is now by itself. That's your whole goal when you are told to solve an equation, is to isolate that variable. But then we just have to remember, again, this is what we quizzed on, what you just turned in. This is a square root term. And then this guy is not. So we can't actually lump those together. We just have to write that as the difference between them. So I would write this as 2 root 2 minus a 5, and that would be one of our answers. Okay. If we do the same thing with that second one, we're going to subtract 5 over here as well. Those are going to cancel. And then similarly, we cannot lump those together as one term because they're not like terms. So we just write this as a negative 2 root 2 minus a 5. Those are our 2 different answers. All right. All right. Remember that, follow that. All right. Then go to 16, do 16. Let's see if we really do remember this, because 16 should be pretty similar to the one we just did. There's one extra step. But see if you now understand this process. Remember, let's write this too. Let's talk about this. We didn't have to do it in that first one. Our first step with all of these is to isolate the square term. We wrote that down on the previous page. The one we just did, that was already done. This square term was already by itself. And by square term, I mean this part right here is already isolated. When we look over here, that's not done yet. So we do have to do step number 1. So there is an initial step that we need to do to isolate that and then go through and see if we can solve it. All right, and let's see where we're at with this. Because we really just need to get these done. I'm going to give you the homework. You should have some time to practice some of this, because this usually the first night is not so good. So let's see where we're at right now. 62. Okay, let's just we're 0 for 3 right now in the first 3 that I looked at. So maybe I'm being a little ambitious here. So let's do this one together. All right, so 16. All right, what we need to do is isolate that square term. So here's something I saw. Let's talk about why we can't do this. If I gave you this here, notice how there is no squared term right here? Just a regular old order of operations. We can distribute here if we wanted to, because we can multiply, that's fine. As soon as I put a squared right here, what gets done first? Exponents? Oops. Exponents or multiplication? If we did order of operations, Armando. Exponents. So we can't distribute this in here, right? We cannot distribute, all right? So what we really want to do first, if I'm trying to isolate the square term, that's what I have highlighted right now in yellow, this 3 needs to go. Think of it like this. Think of it as if I gave you 3, if I get my dumb pen to work, if I gave you 3x equals 24, wouldn't we all know we have to divide by 24, divide by 3 right here? It's the same thing happening right here. This 3 is being multiplied by that quantity. So for us to get rid of that, we want to divide that by a 3. Then the 3 cancels, and the only thing that we are left with is an x minus 1 squared. But then we've got to do the same thing to that other side. And then that's going to leave you with an 8. That has to be your first step. Do not distribute this. You can't distribute. All right. That's our first step. That's what I was kind of talking about. This is what we need to do. We have an extra step to start with. This now should look like the previous one that we just did. The square term is now by itself. That's when you take your square root. So now you're going to take the square root of both sides. The square root will cancel out the square. We get the x minus 1 all by itself, which is good. But we also have to take the square root of the right-hand side. So we get the square root of 8. But like we've been saying over and over again, that's when you get both a positive and a negative solution. So in the next step, you write this as a positive and a negative root 8. Now this is very much like that previous question. So that's kind of why I was hoping we could do that. Now that we would see it like this, pretty much the same exact steps as that previous problem. That root 8 can be broken down, just like we did in the previous problem with a 4 and a 2. Still got the little plus minus in front of it. The square root of 4 is 2, just like it was in the previous problem. But then it's now at this step that you make your 2 different equations. This is really 2 different equations. One of them is the x minus a 1 getting set equal to the positive 2 root 2. And then the other equation is the x minus 1 getting set equal to the negative 2 root 2. All right, so we're really just taking this plus minus sign and we're writing 2 equations with it. And then from there, you solve both of them. We're going to add 1 here, add 1 here. So this cancels. We now have the x by itself. That's our goal. And then again, these are not like terms. So do not try to write this as like 3 root 2 or 2 root 3. Like we can't combine those. You just have to write it as the 2 root 2 increased by 1. All right. And then the same with this one. We're going to add 1 here. These are going to cancel. We cannot lump those together. So you're going to get a negative 2 root 2 plus 1. That is your second answer. All right. All right. Next one. Again, let's just do these all together. You're going to get some homework, and then you can try it. We can walk around and see who's kind of getting it, who's not, and then we can sit with those. Difference with this one, if you notice now, notice how there's this power of 4 here. Okay. So again, our first goal is to isolate. I've been saying the squared term because that's usually what you're going to get. This case, it's this power of 4. So we want to isolate what I have highlighted in yellow right here. That's what we want to get by itself. So what this basically is the same exact thing of. So you don't just have to write this down. But let's say I gave you this. 2x minus a 5 equals 157. So notice how it's very, very similar to what I gave you up here, what I just wrote down. If I gave you this guy down here, everybody would know how to do this, right? Wouldn't we add 5 to both sides? It's the same thing up here. We need to add 5 to both sides as we try to isolate what I have highlighted in yellow right there. So go ahead and do that. What you are then left with is that 2, and then we have the parentheses to that fourth power, and that would now equal 162 as those cancel. This is now similar to the one that we just did. You cannot distribute the 2 here. So don't think I'm going to take this 2 and distribute it, because that quantity has a power to it, and we'd have to do that first. So what we want to do is we want to get rid of this positive 2 that's being multiplied by our parentheses there. And the way we undo multiplication is by division. So we would now divide by 2. These then cancel, and we would get x minus 4th to the 4th power, and then that would equal 81. All right. Then we've dealt with square roots, we've dealt with cube roots, but this whole idea of if I have an x squared, the reason I take the square root is a square root and a square cancel each other out with just a square. When we did the x cubed, if I did the cubed root of x cubed, those cancel each other out. So the cubed root and the x cubed cancel, we would just be left with an x. So if I need to get rid of a 4th power, there is also a 4th root. So we need to take the 4th root of this. The 4th root and the 4th power cancel. All we're going to get is that x. So when we look at this problem, now that we have a 4th power, the way that we get rid of a 4th power, you're going to draw that root symbol. So we still draw that in. But since this is now a power of 4, that has to be the index number that we're going to put right in here. So this is now a 4th root. Now, all that means on the left-hand side is these guys cancel, and you're just going to get this x minus a 4. But when we go to the right-hand side, now we got to think a little bit. This is the first 4th root we've done so far. We want the 4th root of 81. Now, you can do this on the calculator, but what this is really asking you is what number multiplied by itself 4 times, hopefully we would cross our fingers, there is a number multiplied by itself 4 times that would give you 81. All right? Here's how you can do it on your calculator. So why don't you pull this out just so you have it. So when I give you 4th roots, this will work for cubed roots as well. So pull that out. I got to remember where it's at myself. There it is. Okay, so let's quit. All right, so on your calculator, let me move this down a little bit. It won't let me. All right, on your calculator, find the math key. It's right here. All right, so if I hit math, if I scroll on down, see how there's a cubed root right here? So don't hit that one right now, but just let me show you. If I hit that key right now, see how it gives me the cubed root? Let's say I do the cube root of 8. That's one of our perfect cubes. It's 2, right? 2 times 2 times 2. If I now hit the cube root of 8, see how it's going to give me a 2? If I did the cube root of 27, that's one of our cube roots that we're supposed to know for our quiz. So if I hit that and I do 27, this is going to give me 3 because it's 3 times 3 times 3. If we go to that key again, so everybody look at this menu. Do you see a 4th root anywhere? No, we have a cube root. We don't have a 4th root. That's because when would they stop? Do they want a 4th root, 5th root, 6th root? We can do as many as we want. So the one that we want ultimately is this guy right here, because you're going to put in whatever root you think this is. So go ahead and hit the X root. And then it kind of depends on which software you have here. So hopefully yours will all look like mine. When I hit that, I want a 4th root. So hopefully yours looks like this. If it doesn't, let me know and I can come look at it. When you hit that, does it look like this?
No, mine says answer on it.
Is the answer on it? I think it. What I would do is just highlight it and put it in 4. Anybody else that look like this? Okay. Notice how it's going to let you put in whatever you want. We want a 4th root. So just type in 4. And then we want the 4th root of 81. And again, I'm just getting this from our problem right here. I'm putting this into the calculator, the 4th root of 81. So now type in your 81, and then you cross your fingers. It's a nice number. If you're not sure, we cross our fingers. Is this a nice number when you hit enter?
Yes.
Yeah, what is it going to give you?
3.
3. So that means 3 times 3 times 3 times 3, 4 times is going to give you 81. So that actually gives us a really nice number of 3 over here. All right. But remember, come on, you. This should also give you a positive and a negative 3. And here's why. Wouldn't a negative 3 multiplied by a negative 3 multiplied by a negative 3 multiplied by a negative 3, this is a positive 9, times the next negative 3 is a negative 27, but then I have one more negative 3, and then isn't a negative times a negative 81. So wouldn't 4 negative 3s also work? So it's the positive 3 and it's the negative 3. Do this for me real quick. Get your 2 answers. See if we're understanding. At least show me that we understand that. How am I going to get my 2 answers right now? Okay, how do we set up the 2 equations from here? You actually get really nice numbers here. You don't have to worry about any weird radicals. Get your 2 answers. Set up your 2 equations. Get your 2 numbers. Okay, let's see where we're at here. So our first equation, you're going to take this here, the x minus a 4, and this just means we have 2 different numbers. One's a positive 3, one's a negative 3. So we're going to set it equal to positive 3. And then our second equation, you're going to take the x minus a 4 and set it equal to the negative 3. Those are our 2 equations. You then solve those real quick. So you're going to add the 4 to both sides. And the first one, you should get a value of 7. So that's one of our answers. And then the second one, when we add the 4 to both sides, you should get the value of 1. All right. Because all of these questions are going to boil down to that step. You got to be able to set up your 2 equations and understand how to solve those. Okay. All right. The last one I want to do together, because I want you to kind of get these started a little bit so we can kind of keep an eye and answer any questions. Go up to 14. Go up to number 14. Same steps. We want to isolate this term right here. We want to isolate the powered term. So in this case, we want to isolate 2 cubed, or the x cubed. So again, don't overthink it. If I just gave you this, wouldn't we all know that we have to divide by 2 right there? It's the same thing with this. Since this is a product, we want to divide this by a 2. So do that. So those are going to cancel. We get x cubed equals 27. All right, say that again, Asad. Okay, what do we do to solve this now? If I want to get rid of a cubed, what are we going to do to both sides? Armando? Good. We're going to put that root, and we're going to take the little 3, means it's a cubed root on both sides. So we're going to put this as an x. And then we're going to take the cubed root of this number too. Let me give myself a little more room so you can see it. So this is our 27. So I'm going to take the 27. I also need to do the cubed root of 27. All right. So now, this another last little layer of things to be really, really careful of. Every problem we've done when we've done this root here, square roots and cube roots, remember how I've always have told you to put this plus or minus right here? Here's why we want to do that in certain situations and not other situations. So let's not put that just yet. What is the cube root of 27? I actually just put it in the calculator. Is that? Yeah, it's 3. 3 times 3 times 3 is 27. All right. So now think about what that means. If I did the cube root of 27, what I am looking for is 3 numbers that multiplied, same exact thing, that multiplied to be a 27. Do we agree that a positive 3 times a positive 3 times a positive 3 will give you a 27? Yes. Let's check this one, though. If I give you a negative 3, because that would be the whole little plus minus, if we're going to use that or not, negative 3 times a negative 3 times a negative 3. What's the first 2 going to give you? What's a negative 3 times a negative 3? 9. And then what's 9 times another negative 3? All right. So do 3 negative 3s actually give us this positive 27? No. So when it is an odd power here, so notice how this is an odd number, odd index number, you do not put the plus minus because the signs won't work out for the negative. Notice when we did do it, we did it with an even power of 4, and we've been doing it nonstop with all of these square roots. And a square root is obviously, I erase this one. A square root is obviously a power of 2 that is also an even number. So we only need these little plus minus signs if it is an even power. So in this case, this is your only answer. That is the positive 3. You are not putting the little plus minus sign here if it is an index number that's odd. All right. A lot of layers to these. This is not easy. Okay. Probably the hardest thing we've done up until this point. Okay. So I want you. Here's the homework now. So we'll see how this goes. Okay, with this time, I want you to start now. So I want you to hide this in your folder, pull out your phones, and look at that thing. Try this out. I want to kind of see where we were at. I actually like you to kind of start with number 7, because that's all these equations that have all these different steps to them. And then we can kind of see where we're at. If you're not understanding, use these 10 minutes to ask a question. All right? Because again, this is pretty tricky. So you're just going to do all of these 1 through 20, but I start with 7 because 1 through 6 should be pretty quick. So start with 7 and see how we do with these. Okay.